Good morning, everyone. Let us come to the topic of microarrays, okay, which is important in your applied bioinformatics. So the aim of this session is to conceptual basis of microarray, and the learning outcomes are to define the conceptual basis of microarray and to describe the key parameters which is used in a microarray and some advantages and the limitation. So what is microarray? Is a laboratory tool used for molecular biology, okay, in genetics to express, analyze the gene expression, or you can find the SNP. So it allows anyone to study thousands of genes and proteins simultaneously. That's what important is. And microarray technology is based on the principle of hybridization, where the target molecules such as DNA or RNA bind to the specific probes on the microarray surfaces. And microarray consists of small solid supports such as glass slide, silicon chip, where you can it's like a dots, and which microscopic dots are there and arranged in a grid pattern. Each spot consists a specific probe, which typically a short segment of DNA or RNA that is complementary to the specific gene or gene sequence of the interest. So what is the production? How you do produce a microarray? First, there's a slide making and experimental step is there. First of all, you have a target design and selection, then you go for the printing, right? Then you go for RNA extraction, labeling, hybridization and washing, scanning, and finally you do perform data analysis. So what are the, as I was saying about the SAGE analysis, so what we do is the difference between SAGE and microarray is detects unknown transcripts. SAGE, yes, microarray, of course you don't know, because that's depends on the hybridization, right? So you don't know about whether it can detect unknown transcripts or not. Quantification is absolute, and microarrays, of course, it's relative. Sensitivity is high, and microarray is moderate, and specificity is moderate. And microarrays is very high, because again it depends on the hybridization technique. So direct cost is 10x higher than the arrays, of course, and SAGE and microarrays, because you are doing together in a pool, okay, so it is less expensive. So this DNA microarray station, okay, this is how it looks. So you have a probe which integrates to a slide by chemical reaction. Robot, you use robots, okay. Microarray fabrication is used. Then the cDNA of interest is bound onto the slide, so that all the extracted cDNAs can be checked, and it is labeled the cDNA molecule that's allowed to specifically bind to the genes of interest, okay. So how many genes are there, you can bind it. It will bind, and it is the cDNA sequence, because mRNA is not stable, of course you convert it into the cDNA, right? And what are the target samples that are checking against the probe? Is targets are those sample that are checked against the probe. So first you have you have to integrate the probe onto the chip. You have to print the probe onto the chip. Then you use CD sequence of all the control and test sample, and that allowed to bind to the probe, and sequence of various genes that are supposed to be controlling any cellular response in any condition. You can find it. Finally, you also have sequence length from 25 to 60 bases, although maybe of 100 to 1000 bases long as so. So they are labeled with Psi3s, Psi5, which you can also use for protein quantitation, right? So there are different signals, fluorescent signals, what you are using with the microarray. So here you see this is a chip, and this is the probes what you are immobilizing on the chip, and you have a target DNA which is hybridizing. So this is a stable hybridization, and this is unstable hybridization, of course. So when there is hybridization is happening, so mutual binding of sequences is called hybridization, of course. So increased degree of hybridization leads to increased microarray accuracy. That's important. So once it is hybridized, and there will be a signal which is coming out. So synthetic oligos, generally when we are using, you are using 25 to 70 bases length and so on, and you are using complementary mRNA interest. So you avoid generally A plus T and G minimize internal secondary structures. Those are important, because you try to minimize the unstable regions and so on, okay. So this is the basic method. You have for example, if I want to do together, like I want to compare between normal and tumor samples, right? So So I'll do the cDNA analysis, and because there is already the probes which is there on the chip, I'll try to hybridize them, immobilize the probes, and I'll use both the cDNA probes, and I'll try to scan on this. Fine. So these are the general method of using microarray. Now you know microarrays are being used in most of the laboratories. Now I'm not saying that, but most efficient method is NGS has come up with, right, next generation sequencing. So it allows the expression also of 20,000 genes simultaneously. That is what's important is. Okay, I hope you understood the concept of microarray. Thank you so much for your attention.